All right, here we are back doing 7.5, and what we're going to be working with is exponential logarithmic equations and inequalities. Now, to solve exponential equations, what we're going to be kind of doing is trying to write them, if we can, with the same base. All right, or if we can't, just take the log of both sides and then remember our log properties that we've kind of talked. So once again, hopefully, when we use a rounded number, if we're checking it, it should be close. Sometimes when you round it, it won't be exact, but it should be close enough. As we do some multiple choice, the way you round and I round might be a little different, but you should be able to see which one it is. All right, so how do we solve something like this? Ay caramba, yeah, we're looking at this. Okay, well, the first thing to do is to see, can we write it with the same base? Well, we have a base of 9 and a base of 27. Well, here's kind of sneaky thing. 9 can be written as 3 squared. And then, of course, we'd have 8 minus x here. And 27 is the same thing as 3 cubed. Ha ha ha. X minus 3. All right. Well, remember our properties of exponents. Power to power, we multiply. So what we have here is we're going to have 3. If I multiply those, we're going to get 16 minus 2x. Here, if I multiply by 3, we're going to have 3 to the 3x minus 9. Well, now that I have the same base, if the bases are the same, that means the exponents have to be the same. So let's take 16 minus 2x, set that equal to 3x minus 9. All right, I might add the 2x over here to get 5x, add the 9 over here to get 25, and then divide by 5, we'd find out that x is actually 5. Look at that. Is that ever neat? Wow. Yeah, that takes a little bit of work as we do that. But yeah, if you put it back in, you will check it does work as we do it. So that's one way, is if you can write the bases with the same base. That's the exponential equation. That's kind of the tricky thing to do. These are tough. Yeah, these aren't very easy. All right, now this is a case where our base on this one is 4, the other one is 5, 5 to the first. So we really can't get the same base. So what we're going to do is we're going to take the log of both sides. And like I mentioned in the previous section, one of the great things about the log property is if it's raised to an exponent, we can take that out front. X minus 1 times the log of 4, that equals the log of 5. All right, well then what we can do is we can divide by the log of 4. So we have x minus 1 is going to be equal to the log of 5 divided by the log of 4. And then, of course, x would just simply be 1 plus the log of 5 divided by the log of 4. All right, if we wanted to go over to the calculator, we could certainly do that. Let's see if we can't minimize this. All right, so let's clear, and let's see. So let's take the log of 5 divided by the log of 4. There we go, we get that. And again, this is where that rounding comes into place. We're just going to add 1 to that. And so 2.16, 2.2, depending on how you want to round, there's your answer. Ooh, okay. All right, good enough. All right, that's good. All right, let's try a couple more, because like I said, some of these aren't very easy. All right, now once again, we have our base of 3 and then another one of 27. Well, as we learned before, this one has a good base already of 3. We can rewrite 27 as 3 to the third. Well, in which case, 2x has to be 3, and in which case x would have to be 3 halves. Ta-da! There we are. That one worked pretty easy. That was a good one. Always look for bases like 2, 3, 5, those types of things. All right, now this one, I can't get it as the same base. So what we're going to do is we're going to take the log of both sides, log of 7 to the negative x equals the log of 21. All right, so we're going to put that exponent out in front. All right, and then we're going to divide by log of 7. So we're going to go log of 21 divided by the log of 7. Now remember, that's what negative x equals, so x is going to be the opposite of whatever that is. All right, so let's go to our friend the calculator, and we're going to take, let's clear that, let's go log of 21 divided by the log of 7. And there we go. And again, so that's what negative x is. So x would be the opposite. So I'd say negative 1.56 is what we would see there. All right. So there's some good things as we go. Yeah, kind of some good problems to do there. All right. Now, some other things just to remember: if log base b of x equals log base b of y, then x has to equal y, obviously, as we look at some of those properties. Make sure we review our properties of 7.4, that we still have those available as we set up and solve these. So, like when we do something like this, so once we get it as a singular log, always kind of look at putting it in an exponential. So let's say 6 to the negative 1 is equal to 2x minus 1. Well, we know that that's 1/6. So if I add the 1, that would be 1, and 1/6 over here would be 2. And then if we divided that, well, that's 7/6. So if we divide that in 2, that would be the same thing as 7/12. Yeah, again, you can use fractions or decimals, whichever one you're comfortable with. So these can be kind of tricky. All right, other properties. Remember that when we have the same base, we can write it as a singular log. That's always what we want to do. Remember, we divide those. So we're going to go 100 divided by x plus 1 equals 1. Let's convert that to an exponential. 4 to the first power is 4, and that's got to be equal to 100 divided by x plus 1. If we multiply across, if we take the x plus 1, we multiply that by 4, we're going to get 4x plus 4 equals 100. So if we subtract 4, we get 96, and x would then be 24 is what we would see if we divided by 4. Okay, so those are some sneaky problems. Remember your properties. Always try to write it as a singular log, then convert it to an exponential. That'll be your best bet. All right, some other things as far as going through using tables and graphs to solve like inequalities. You can just go ahead and type in the 2 to the x plus 1 as y1. Type in 8,192x as y2. You can graph it. You can certainly do that on Desmos as well and kind of use the view window and kind of see where one is bigger than the other. You can always use that. It's kind of a good thing to use. Desmos is kind of a nice thing to have there. Or you can put it on a table and kind of scroll up and down and see when the first one is bigger than the second one. So, you kind of say it's, when x is greater than 16, that's, 16 is when they're equal. So the first equation is bigger than the second once you get over 16. So there you go. So that's 7.5. There's some tricky ones in there. So, work on those. We can certainly meet up on the Google Meets and go through a few of those from the assignment or anything else. So it'll be a little challenging. So do the best you can and use those properties. Make sure you use those notes and we'll see how it goes. All right.